Now, one thing with functions that sometimes causes students to struggle a little bit, and particularly at the beginning, is because this particular math class is kind of a language-based math class. It's not just, oh, here's question number 1, and there's a whole bunch of numbers, and you know what to do with the numbers, and you're done. There's going to be a whole lot of words. You're going to have to read. You're going to have to pull out. You're going to have to learn notation. So we're going to talk about that language first, as well as I will reinforce it over and over and over again in notes. All right, so I highly recommend you get familiar with the language. Once you get that done, it becomes a whole lot easier. Okay. All right, so obviously this is a functions class, so we have to know what a function is. So a function is a relationship that shows how one quantity depends on another. One quantity will depend on another. All right, so what does that look like? Well, there are 4 different ways it can be expressed. So we're going to look at the first way. And that is when you were provided a formula or an equation. Here is a formula or an equation. It is I equals PRT. So mathematically, that means I equals P times R times T. All right, well, what is I? This is actually an interest formula. So what this means is interest is equal to principal times rate times time. All right, so for notation for this class, here's what you need to first learn. This right here is what we call the function. So in this formula or this equation, I is your function. These 3 letters are your variables. So in this case, we have 3 variables. All right, now notice I circled the word depends in that sentence. So in this particular, all that water to go on you. Okay, so what depends on what in this particular equation? So in this particular equation, the amount of interest depends on the principal. Whoops, I got an extra L in there. Principal, rate, and time. So what that means is I won't know my interest until I know what the principal, rate, and time are, because it's dependent upon it. So that would mean principal, rate, and time are independent. Okay. All right. Second way we can look at a function is with a table, or also known as correspondence. So this is an XY table. I'm sure at some point in your math background, you probably did one of those. Notice we have pairs. Does anybody know what that 0 and that 4, it's a pair? We would call that here's my hint. You may see it like this.
Oh,
Ordered pair. Means there's a particular order. This is also known as an ordered pair. So from a table, that allows you to create ordered pairs. So we would have 0, 4, another ordered pair would be 2, 6, another ordered pair would be 4, 8. Now, what that corresponds with is at some point in your math background, you graphed ordered pairs. So the horizontal line is known as the x-axis, and the vertical line is known as the y-axis. So like the ordered pair 0 would mean on the x-axis, you don't go anywhere, and then you would go up 4. So that point would be right there. And then 2, 6 would mean go over 2 and then up 6. And so that point would be right there, and so forth. When it is in a table, the X value is what we call the input. This would be considered your variable. Bless you. The Y value is considered output. This would be your function. And the function is always dependent upon its variables, always. So think that function is dependent upon variables. Okay, so that would mean in this case, the Y value, which is considered your function, depends on the X value, which is considered your variable. So the function always depends on the variable. Function depends on the variable. Always, always, always. Okay. All right. Then a more problem-specific type graph is given here. So we're given numbers, we're given years, we're given values. We look at a graph. Okay. So if the horizontal is our x-axis and the x value is always the variable, then that tells me this axis is representative of my variable. And what is my variable? The date. The vertical axis always represents my function. And what is my function? Canadian dollar. All right, so what always depends on what? Function depends on variable, variable depends on function. Which one? Function always depends on variable, right? All right, so if I asked you to explain this in sentence form, I can't just say function depends on variable. I have to be problem specific. So I go, okay, function. What is my function? Canadian dollar. So I would say Canadian dollar depends on, and I know it depends on the variable. So I look, what is my variable? The date. So my function is the Canadian dollar. My variable is the date. Function depends on variable. Always, always, always. Okay. All right. Then the fourth way is in words. And that's what we will be seeing a lot of, whether that be examples we do in class, WebAssign, quizzes, tests, is you're going to see words. You're going to need to be able to pull this information out. And that is difficult for some, and particularly at the beginning, because we a lot of times don't think math and words go together, right? All right, so words. This says a plumber charges $50 to make a house call and an additional $35 per hour. So we're talking about charges and we're talking about hour. All right, so we've got to figure out which one of those is representative of the function and which one would be considered the variable. All right, so we're talking about charges or cost, right? A plumber, he comes to your house, he's going to send you a bill. And then what else are we talking about?
Additional charge.
An additional charge based upon what? Hours. So we're looking at charges and we're looking at basically number of hours. All right, which one is dependent on the other?
The
Charges are dependent on the hours, right? Because if my plumber works 1 hour, I'll get charged that amount. That is dependent upon, now if he works 2 hours, I get charged another amount. So if charges depend on hour, what's always first? Function or variable? Function. So function is my charges. I'll call it C. Which would make my variable what? Hours, which I'll call H. Now, notice it said the plumber charges $50 to make a house call and then an additional. This, they just show up at your house, bam, you're charged $50. That's called a fixed cost. Then the $35 per hour, obviously the plumber works 1 hour, I'm charged an additional $35. If the plumber works 2 hours, I'm charged an additional $70. Okay. All right. So that's just some foundational work. So now we're entering section 1.1. This formula right here is based upon this example that we just did. C is representative of charge. That formula is $50 plus $35 per hour. So if I asked you based upon this formula to define, you would define the function as C, charges. I'm just going to write it again. It's the same thing. You would define the variable as H, which is hours. It's always function equals, and then in the equation, you'll find the variables. And in this case, there's just one. Okay. All right. Now, part of the verbiage that you're going to need to learn, whether that be answering questions in WebAssign or when I ask you in class or on a quiz or a test, because if you're asked this question and you just start trying to pull things without some thought behind it, then you're not going to get it correct. Okay. So we've already talked about function and variable. So if I asked you what is the function, you would say C, that's your charges. If I asked you what is the variable, you would say H, that's number of hours, right? There's another wording that you've got to know. So here's my equation. We know that C is the function and H is the variable. If I asked you what is the functional notation, all I'm asking for is that. And this is C at H, which is basically my charges at H hours. Now, notice here, it gives you C2. This is the functional notation with a value for the variable. So what does that 2 mean? 2 what?
2 hours.
Hours, right? So this actually means what will my charges be? So this is my charges at 2 hours. This, if I asked you what is the functional notation, that would be all that you give. Then if it went on and said calculate it, they actually did that here. They substitute 2 in for the H, they calculate it, so we would be charged $120. Okay. So the main things, and we'll be doing a lot of defining of it, is if I ask you for the function, you got to know what I'm asking for. If I ask for the variable, you've got to know what I'm asking for. And if I ask for the functional notation, you've got to know what I'm asking for. Okay, so here's some examples. Here's the type of work that you would see. Now, all right. Especially at the beginning and pretty much for the whole semester. I don't just read a problem and give an answer. I read the problem and I determine and define what was given. Then I go to answer the question, because more than likely that things that I have defined will make answering the question a whole lot easier. So if you're trying to hurry up and you just want to pull it out without taking the time to define the information, then you're running the risk of missing problems more often than someone else. Okay. All right. So do I have some college athletes in this class? Okay. What sport?
Baseball.
What position?
Pitcher.
You're a pitcher too. Same one. I had a baseball and it was so do you bat? You
No.
probably don't bat. Okay. So you're a pitcher. What is something that you do to get better at your craft in practice?
Throw bullpens.
So you get in the bullpen and you throw and you throw and you throw, and we work on this pitch and we do it again and again and again, right?
Yeah.
Why do you do that?
Get better.
Oh, wow. It actually helps us get better. Not any different in math, y'all. Right? So you may get tired of me writing some things over and over and over. It's because I want you to get better at it. Right? Not any different than a baseball player, if you play basketball or soccer, whatever your thing might be. The more you do it, the better you get at it. All right. You think Simone Biles never practiced her day in her life? I'm guessing she did, right? And she's the GOAT. All right. So here's our problem. If P at T is the profit I expect my business to earn T years after opening, use functional notation to express my expected profit after 4 years. All right, so first thing that I want to do is define the function. All right, do you see anything up there that would lead you to go, that's what I'm going to look at to define my function and my variable? Do what? Okay, we are talking about profit. And do you believe that to be the function or the variable? The function, that's correct. Okay, so the profit is dependent upon what? All right, so look here, we've got profit is dependent upon T years. Also notice T is in the parentheses. What will always be in the parentheses? The variable. Okay, so my function, I'm going to define it as P, which we said was profit. I'm going to define my variable, and it is in the T is in the parentheses. So T, and you told me that was years. Okay. All right, so that's my practice, right? Now, here's the actual question being asked. It wants me to write in functional notation to express my expected profit after 4 years. All right, well, what is this? How would I define that?
The variable.
That's my variable. So we know T is equal to 4. So how do I put that 4 into functional notation?
E at 4.
P at 4. So the actual answer to this question is this right here. But I take the time to define all my information. Now it's not asking me to calculate anything yet, right? It just wanted to know functional notation. That's all there is to it, okay? Now, in the second example, they give me a formula right here. Okay, so let's read this information. There is a formula that estimates how much your puppy will weigh when it reaches adulthood. The method we present applies to medium-sized breeds. First, find your puppy's weight, lowercase w in pounds, at an age of A, weeks, where A is 16 weeks or less, then the predicted adult weight, W equals W at A comma W in pounds, is given by the formula. Okay, so you start reading that, and I get it. You can start feeling bogged down with that, right? So we're gonna break it apart. So first, I'm given this formula right here. All right, y'all, we talked about formulas back here with this example. So if I'm looking at the formula right here, what would you say W is? Function or variable?
Function.
Function. Function is always first. All right. So just based upon the formula they gave me, I can define function as W. Now I've got to know what that is. So, okay, it is weight, but be careful. Weight specific to what about the dog? When they're an adult.
Oh.
So this is the adult dog's weight. Okay. Then we're going to look at and define our variable, but in this case, how many do we have? Two. So I have two put an S here. Variables. Okay, when I look here, I have lowercase w. So there's a difference between uppercase W and lowercase. They're not the same variable. So let's look up here. Here's my lowercase w. What does it tell me about that?
The puppy.
That's the weight of the dog when it's a puppy. So this would be puppy's weight. And then I have to be a little bit more specific. What do I have to include? Pounds. All right, and then we have A. So I look up here. Now, I get it. You might read this age of weeks, but this is A weeks.
Yeah.
So A is the puppy's age in weeks. Now you can't say just puppy's age, right? Because if I said 1, if you said my puppy's 1, I would assume 1 year. This is talking about weeks. So you have to be specific on that. Okay. All right. So then once we get all that information here, notice they tell me the function equals. All right. So they tell me that W is equal to W A lowercase w. Now, here's why this is so helpful. Okay. All right. This says use functional notation. So again, my answer is just going to be a functional notation. I'm not going to calculate it. Use functional notation to express the adult weight. Well, notice W, this is the adult's weight of a puppy that weighs, there's a number missing here. This is supposed to be weighs 3 pounds at 11 weeks. 3 pounds at 11 weeks. Okay, well, we said that, so they give us 3 pounds. I look up here, is 3 pounds W or A? It's lowercase w. And then we're given 11 weeks. And of course, I'm only left with the variable A, which is the puppy's age in weeks. So we know this is lowercase a, right? Now, here's why, another reason it's so helpful to define everything first is because notice when I put it in functional notation, I have the function W, and then notice A has to go first. And A is 11, 3. And if you don't pay attention, I'll have a lot of students that in their haste would write W 3, 11. because the number 3 came first in the sentence before 11. So you have to be careful. That's why it's important that you define the information. Now, what is the actual answer? Functional notation is that W11,3. Okay. All right. Now notice in B, it says calculate. Okay. Before we do that, and we'll get our calculators out and we'll do that. But before we do, all right, y'all, I'm a math person. I like math. I've done a ton of math. Lots of high school classes, lots of college classes, took my master's. I am a write everything down as I go. Not everybody's like that. Some of y'all are. I want to pull out my numbers, throw it in my calculator, give you an answer and move on. All right. Now, come test time, you may very well do that. And if you get the right number, provided I didn't ask for additional information, I would give you full credit. But I'm telling you right now, if you'll take the time to write it down like I'm getting ready to, you'll make less errors. And then if you accidentally enter an incorrect number on your calculator, if you give me an answer only, if it's worth 5 points, I'm taking all 5 points off. If you show me your steps that I could see they had all the right numbers in the right places, they must have made a calculator error, I can give you the partial credit. So, and believe you me, I say all the time, I would not have a math degree without partial credit. I was not brilliant to never miss a question, right? So I survived and got my math degree because of partial credit. All right, so calculate the predicted adult weight for the puppy. And then it says round your answers to 2 decimal places. Okay, all right, so calculate. So I'm going to go ahead and write W at 11,3. I'm going to come up here and I'm going to put all the correct information. Now, here's where you need to be careful as well. This means 52 times. So you can put a dot or you can put parentheses. Now, I'll have a lot of students that will put 11/3 because, hey, there's a W, that's the first number. Look, A is the 11. That's why we define everything. So the 11 actually goes on bottom and the 3 goes on top. Okay. All right. Calculate that and tell me what you get, please, if you have your calculator. And then I'm going to show you a couple of things on your calculator that might be new. Get a fraction?
Yeah,
All right, what did you get?
for the 14.88.
Okay, that's the decimal. What was the fraction?
156/11.
Okay, so the decimal's fine and we're going there, but I want to talk about the fraction. Some of you might have gotten 156/11. Well, if you're asking me for the weight of my dog, which by the way, my dog's name is Hopper, I would not say, oh, Hopper weighs 156/11 pounds, right? Okay, so I'm going to show you a couple things on your calculator that you may not know. All right, first off is how to get the fraction on your calculator, okay? All right, so I'm going to put in 52, and I'm going to put in the open parenthesis. All right, then the green button on mine, it says alpha. I'm going to push alpha and then come up here and push this Y equal button. Notice that number 1 has N/D. That's representative of numerator over denominator. That's your fraction button. So I'm going to push 1 and bam. Now I can put in what was on top 3.
Yeah, 3
And then come up here and push your down arrow. Put 11 in, push your right arrow, close your parenthesis. And then when I hit enter, I get 156/11. And I'm like, I want the decimal. Okay. All right. Clear it out. On your calculator, find the button that says mode and push that. Now, down arrow, down arrow, down, 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 go to the next page, down, down, and you're gonna see where it says answered. And mine was set at auto. I'm gonna right arrow over. DEC is decimal, and then you have to push enter. Now I'm gonna clear it out, and I'm gonna re-put it back in and see if that fixed it. So 52, open parenthesis, alpha y equals 1. 3, was that right? 3/11? Yeah.
Mhm.
Close parenthesis, enter, and now I get my decimal. Okay. All right, so this is the answer. What do you need to do again?
Redo it. It figured everything out when I was doing
Did you get it changed to decimal
No.
answers? Okay, go to mode. Then down arrow to the next page. And do you see the word where it says answers? Okay, go to answers, right arrow over to where it says DEC and then hit enter. And then clear it out. All right, okay. All right, now, this is the answer that you get. Now, notice it says round your answer to 2 decimal places. So here's the decimal point, 1, 2. So I'm gonna round my answer to 2 decimal places. We're gonna use normal rounding rules. So those of you that may have forgotten, I look to the next number. If it's a 5 or larger, I would have 14.19. Since that is smaller than 5, I leave it 14.18. So we get that W equals 14.18. So this is my function. Okay, so if this were on a test and you get 14.18 and that's all you give me as your answer, I'll give you most credit, but I am going to count at least a point off. Does anybody know why?
Because you didn't have the pounds.
I need to tell what I'm talking about. I will be picky about that. I will count off. Okay. Now, what is this talking about? 14.18 pounds for the adult puppy. Is that an oxymoron? Adult dog. Even when our dog's old, it's still our puppy, right? Okay. All right. On example 3, we're going to define function and variable, and then we're going to call it a day. Okay. All right. So the height of the winning pole vault. Anybody watch the pole vaulting during the Olympics?
Kind of.
I watched a little bit of the men's. I don't think I saw any of the women's, but the guy that won it, he broke the world record, which was pretty amazing. Do you remember where he was from?
Sweden.
Sweden. Yeah, Sweden. Thank you. I know it was like me. I don't know.
Ukraine or Sweden.
I think it was Sweden. I'm pretty sure. But it was, yeah, it's pretty cool. All right, so the height of the winning pole vault in the early years of the modern Olympic Games can be modeled as a function of time by this formula. Okay, so just with looking at the formula alone, without knowing maybe what the letters represent, what letter is the function and what letter is the variable?
H is
Mhm.
variables T.
Correct. Always, always, always. All right, so I know the function is H. I will say most often it's a capital letter, but it doesn't have to be. So be careful of that. Okay. All right, so let's keep reading and see if we can know for sure what H represents. Here, T is the number of years since 1900 and H is the winning height in meters. So right there, it tells me H is height in meters. So I would put height. And I have to express that that is in meters. Right? Because here we usually talk about feet, but obviously they do meters in the Olympics. All right, so my variable is T. So I'm gonna go back and look again, and it says, what would you tell me T is? It is, I'm gonna include this and I'm gonna tell you why. So T is years. And I want to include since 1900. Here's why. Because if I said T equals 1, if I did not include since 1900, you wouldn't know what year I'm talking about. So if T is equal to 1, what year is it? 1901. So it's important to know where it started at. Okay, so those are some important things that you need to be able to define. Okay, so that's where we're gonna stop today. We'll pick up on that one on Friday, okay? Now, you can start putting your stuff up, but don't leave yet.